we actually get this running under its own steam at last. I hope. So what I'm going to do is I've just finished putting all the plugs on the end of this umbilical cord, and we're going to connect it into the electronic control box that I've finished this morning making, and so we'll do that right now. So you can see I've marked everything clearly on here, so you know, we don't get confused plugging these in. So I'll just plug these in and get back to you. Okay, so we're all plugged in. Got the earth connected here, which gives an earth to the chassis of this. So let's turn it around. So now the big test is to see whether they actually work. I am going to have an external on-off switch, but I haven't actually sorted that out yet. That actually turns on the main power supply there for the stepper motors. So first of all, we'll press the reset. There's no alarms of any sort, so you know, I'd say it'd be all okay. I'll just zoom you in a little. Let's see if we can get something to move. So I've just taken the reset off, which is done by this button here, a cross with some dots on. I will later on give a close-up of this panel and take you through some of the screens to set up some of the motor parameters, and actually hopefully I'm going to get the limit switches on here and get those set up in here, and the soft limits. We'll see how it goes, see if it all works first. So we're going to try the x-axis first. Oh, whoa. That works fine. Y. And Z. O. That's working actually in reverse to what we need. So we'll put that right first, and I'll show you how to do that. Now you can either use this selection wheel. This also acts as an MPG as well if you wish. But we're going to use a combination of this and these buttons. So we're going to press OK there and come to motor set. OK. Now the one we need to alter direction of the stepper motor is this one here. Direction. Now we need to alter that figure there. Incidentally, these are general settings for stepper motors. Now we are not tuning the stepper motor, so we're not going to alter any of these. So what we're going to do is go to here, press OK, press 1. Okay, so this is either 1 or 0. Then press it again till it goes red. Then you can move the selector. Now you must come back and save. Okay, and exit. And you can actually use the direction arrows to move around the screen. Now press reset. Now I'll zoom you back out and we will test the Z-axis. Okay, Z-axis, up and down. So that's how to correct that. So it's very, very simple. It's just like Mach 3 or Mach 4, but built into one unit. You know, it's laid out very similar, really. And we will together, you know, sort of go through every part of this controller over the next coming months, so we get a full understanding of the total operation of this SMC5 unit. Okay, now for the moment I have the spindle set up to operate separately, but I do intend in the future to operate the spindle from the SMC controller. It has the ability to operate either 0 to 10 volt, which is, I understand how this spindle power supply operates, or it will operate a normal type CNC spindle via VFD. So what we're going to do is I'm just going to fire up the spindle, because that was the last job I did just now, actually, was plug the spindle in. So and I've got that operating on a separate switch as well. Oh, that is so quiet. That's doing about 5,000 or 6,000 RPM. About 8,000 or 9,000. About 12,000. Actually, the noise that you can hear is the fan on the top, and it's actually blowing quite a bit of air. Let's take it all the way up. That's 20,000 RPM. Well, I'm pleased with that. That's quiet. It's no louder than any, 1.5 kilowatt air-cooled spindle. It's no louder. It's about the same. Obviously, a water-cooled one is quieter because you don't have the fan noise. I mean, most of that noise, I'm sure you heard yourself, was the actual fan on the top, which blows quite a bit of air, actually. I'm well pleased with that little spindle, actually. It seems that it is, there's no vibration there. I got my arm on here and I couldn't feel the thing running at all. So it's very, very well balanced. So I'm very pleased with that. Okay. So what I want to do now is check to see. The next thing I want to check is the pendant that came with this. So I'll plug that in, get that all plugged up and turned on, and we'll see how that performs. Okay, one pendant, and I've just discovered a very nice touch. It's got a very strong magnet in the back of it, and which is nice. You'll attach to the panel with magnetism if I wish. So we'll turn this on. Okay, green light comes up on here. Release that. Lower setting. We're on X. Oh, extremely controllable. I'll zoom you in a little. that is very, very controllable. Very, very controllable. Okay. Very controllable indeed. That works very, very nicely actually. I'm happy with that. What I want to actually find out is how far this is going to come forward, and I want to line up with both sides, and because I want to find out where I'm going to put my limit switch. I think I'm actually going to mount, I may mount the switch here, I'm not sure yet, or I may mount it actually on here somewhere, but I wanted to see how far forward we come. It's very, very controllable. I'm just going to zoom out a minute. Okay, I'm going handheld here for a moment. I just want to show you something. I've got a bit of light here as well. Okay, so I've just brought this up now manually, and you can see that the end of the bearing there is flush with the end of the bearing. Oh, what I'm talking about, the shiny bit in the middle there. Okay, that's the ball screw, and the bearing cap here, or bearing mount, is flush. Now, around the other side, I brought, I only put this together and I haven't checked anything out, and you'll see here, alright, now these bits of CAD that you see, I'm just using as shims at the moment because I've misplaced my shim material, and to allow all the axes to run perfectly smooth, sometimes it's necessary to shim some of the parts that you've made so they line up perfectly. So you can see now there's a bit of a gap there of about 1.5 millimeter. Now I'm going to show you how to align the gantry. Okay, so what I'm going to do is, if you see in there, all the drivers are all lit up. Okay, so what I've done is I've put a switch in the circuit of this power supply that supplies the drivers here. Okay, so I switched the drivers off. So that in turn takes the magnetism out of the motors, the holding torque. So I can turn this to align. Now that is how you align the gantry up. And now I can turn it back on. And now it will run true together. Okay, so that's the easy method of lining the gantry up so it's perfectly not parallel, 90 degrees with the rest of the machine. It's as easy as that, but you have to be able to turn off the motors but still have the controller functioning, because I have y-axis motor and slave motor, this side, the second one, see the first and the second one. These drivers are connected up in parallel. In other words, they get an identical signal from one stream from the controller, which is down here. You can see here. Okay, there's one stream coming out of pull and direction going to a pair of drivers. That's all you need. That's all you really need. So that's all working. It's all working. I'm very, very pleased.